Okay, the next thing I want to talk about is storage area networks, or SAN. Now, a storage area network typically is accessed via one of several protocols. Okay, we have Fiber Channel, iSCSI, or FCOE, or Fiber Channel over Ethernet. So you see here, it's an external disk array, okay, external Fiber Channel, iSCSI, or FCOE connections. However, it appears as local storage to the host. Okay, it's a block level protocol that to the host appears as though it's a locally attached disk. So we maintain security in this type of an environment through something called zoning and masking. All right, so there's a masking view, there's zoning, there's initiator groups, and so forth. There's a number of concepts within SAN technology that's beyond what you really need to understand here. But just for the purposes of understanding how security functions in a SAN environment, just understand that there is zoning and masking. So that zoning can be thought of as a security boundary. So each host in a storage area network, okay, they're going to have what's called an HBA, or a host bus adapter, and that's much like a NIC, or a network interface card, in an IP environment. Okay, so if they can attach to a LAN via a NIC, they'll attach to a SAN via an HBA. Those HBAs have what's referred to as a WWN, or a worldwide name. That is a unique address, or a unique identifier that identifies that host on the storage area network. So by creating a zone and a masking view, we're saying it doesn't matter that we have, say, let's say that we have 1,000 disks, as you can see in this VMAX array we have down here at the bottom here. There may be thousands of disks in that array. However, we're going to create or carve that up into LUNs, all right, logical unit numbers, or basically blocks of storage, or kind of buckets of storage. That LUN is then presented to a host. That host, because they're zoned only for that specific little bunch of storage, they can only see that LUN. They can't see any of the other storage within that array. So it keeps it very secure. There's no way for them to slip in through the side door, so to speak, and access other data on those arrays. They can only see what they're zoned and what they're masked, the masking view allows them to see. Okay, just to give you a little bit more perspective, here is a DAE, or a drive array enclosure. Okay, that drive array enclosure can have anywhere from, say, 20 to 120 drives in it. And there are shelves that basically pull out of that array. So you saw in the previous example, we had all those storage bays. Some contain engines, some contain nothing but shelves and shelves of drives. Each of these shelves of drives contains hundreds of disks. So you can see in a storage array, we can basically have very large aggregations of disks, up to petabytes of storage in a single array. All right, so just because we have all those disks, however, does not mean that a host has access to all of them. Based upon zoning and masking and so forth, they only have access to a very finite number that we provision to them or allocate to them. All right, also just to keep in mind, the disks that you see in this DAE typically, and again, depending upon the array manufacturer, not all handle things in the same exact way, but typically speaking, those drives are encrypted. So as they sit in that DAE, as soon as you plug them in, they're encrypted, and then that way, even if you were to pull that disk out of that array and put it in another one, you wouldn't be able to access the data on that disk. Okay, that encryption algorithm is specific to that specific array. Gives you that extra level of security so that no one can run into your data center, pull out your drive array enclosures, and start pulling disks out and then run out the back door thinking they're going to go ahead and put them into some other array and steal the data off of that. Okay, it's not going to happen.